I think I am live now. Probably let's just do some mic testing for a minute or so before we get started. It says virtual contest is a way to take part in past contests as close as possible to participation on time. It is supported only ICPC mode for virtual contest. If you have seen this problem, a virtual contest is not for you. Solve these problems in RG. If you just want to solve some problem from a contest, a virtual contest is not for you. Solve this problem in RG, never use someone else's code, and read the tutorial or communicate with other people during a virtual contest. I think I am live now. Like, is my audio and everything fine? And probably people in the chat, like, how many problems were you guys able to solve? This will give me some rest of estimate on like which problems to focus more on, and that's a different. Like, although like my current rank is 48 right now, but I expect my some of the submissions to get hacked over time. Right now it's 48, but I expect some daily hacks on this submission. I think like all of these submission are order n cube and will get TLE hacked, and I expect this submission will pass the system test cases. So and yeah, like it was submitted in the very last minute. So yeah, that's where we are. So like 19:34:26, like just 34 seconds remaining in the contest. I got a one. It started judging only after the contest ended. So that's where we are. I think I will go discuss A, B, C, D, E, F, all the first six problems. I haven't spent any time on G, so I won't be able to discuss the problem. So like, is audio and everything is fine? Okay, famous first time attending live solution. Thanks. So that just ignore to improve. Okay. Okay, CF and yeah, good. Okay, audio is fine. Okay, I think we can get started now. First problem says consider a set of points on a line. The distance between 2 points is difference of I and j, which is I minus j. For point I from the set is the closest point to the point P j from the set. If there are no other point k in the set, so the distance of j to k is strictly less than distance from j to I. In other words, all the points from the set have distance to j greater than equal to I minus j. Probably like looks like a lot of jargon here. Like let's see like what exactly is this problem asking us. So like yeah, if there are some issues with the sound or something, just let me know. Like I can try switching some mics or something like that. And like probably like once it's recorded, like it would be difficult for me to change audio. So like are there some any issues with the voice right now? Hello, hello. Okay, it's thanks enough. Yeah. So like first, like there are some definitions here, but let's take an example to understand what is this problem asking us. Okay, let me also connect with my tablet right now. Yeah, I think we are good now. So yeah, let's look at something like let's look at a set of point 1. 1, 4, 5, and let's say these are the 10 points in our set. And for example, if we now let's say we want to find closest point to like let's say 3. If you look at distance between 3 and 4, the distance is 1. Distance between 3 and 2, the distance is 2. Distance between 3 and 5, the distance is 2. Distance between 3 and 10, the distance is 7. So we would say like the closest point to 3 among these 4 points would be 4. Like the one which has minimum distance. Similarly, like probably let's take one more example with some better set. 1, 5, 10 and 0. Let's find the closest point to 3 here. This distance is 2. This distance is 2. This distance is 3. This distance is 7. So you see like the minimum distance over here is also for 1, also for 5. So we can say that 1 is closest to 3. We can also say that 5 is also closest to 3. Any of these holds vice versa. But 0 is not closest to 3. Neither is 10 closest to 3. And like essentially like you can probably observe that in any set, if you want to find the closest point, either it will be only 1 point or only 2 point. It can never be the case that there are 3 different closest point there. And the way to look at it here would be like, let's say we draw these on a number line. 1, 0, 5 and 10. Now if you see like where 3 stands, there can be 1 point less than 3, 1 point, some points less than 3, some points more than 3. If we look at the nearest point less than 3 and the nearest point nearest point greater than 3, then only they can be the nearest point, because if anything is more than like the next greater number, like this distance will definitely be more than this distance we have. Similarly, this distance will definitely be more than this distance we have. And like 2 points will have same distance only when this point and this point are in the middle for point 3. So for example, if you want to look at point 2, just less than this is at distance 3, just less than this is at distance 3. So for point 2, only this point would be the nearest point. Similarly for point 4, only 5 would be the nearest point. So probably to summarize again, let's say our set is 0, 1, 5 and 10. So for point 2, nearest point is 1. For point 3, nearest point are both 1 and 5. For point 4, nearest point would be 5 and so on. And like now what it say problem statement says? Problem statement gives you some set which is already a set there, and probably let's just see. For example, consider the set 1, 3, 5, 8. Point 1, for the point 1, the closest point is 3, which has a distance of 2. For point 3, closest points are 1 and 5. For point 5, the closest point is 3, not 8, since the distance is greater than 3 minus 5. Like 3, like 8 can never be the nearest point. For point 8, the closest point is 3. The closest point is 5. You are given a set of points. You have to add an integer point into this set such that it is different from every existing point in the set and it becomes closest point to every point in the set. Is it possible? So it says you have been given some numbers and now you have to insert one more number. Let's say we insert the number at this plate, and this new number should be nearest for every point here. But now you see, like for this point, the nearest point would be this, not this orange one. Similarly, for this point, the nearest point would be this, not the orange one. So what you can see is that the new point you add, let's say somewhere, there can be only one point which is less than this, and there can be only one point which is greater than this. And essentially this was the idea for this problem here. Okay, like let's look at, like we should insert the new point at a place such that there is only one point which is less than this and there is at max only one point which is greater than this. So now the solution here was like count the number of different points in a set. Like you can Or, oh wait, like it says all the points are in increasing order. So the answer would be yes. Answer is yes. Only if n equal to 1 or n equal to 2 and ai plus 1 is not equal, or a0 plus 1 is not equal to a1. And like these are the only two yes cases here. Because for n equal to 1, any new point you add, it would be the nearest point because there are just 2 points. And for n equal to 2, you want to add the point in between a0 and a1. So there should be like 1 point between these 2 points. So basically a0 minus a1 should be greater than equal to 2. And like for all the other cases, you can see like the answer will always be no. Because for 3 points, like the situation number line would look like this. If you add a new point here, for these 2 points, the nearest point would not be the new white one. If you add a new point in this range, for this point, the nearest point is this, not the blue one. Similarly, if you add a new point here, the nearest point for this is this orange one, not the pink one. Similarly, if you add a new point here, for this point, the nearest is this, not the green one. And for this, the nearest is this, not the green one. And essentially, this was the idea here. Okay, wait. Okay, n equal to 2 was also given to you. So, yeah. So, there is only one yes test case. Like, I did a lot of solutions here. Like, sorting, etc. is not required. Is greater than equal to 2. C out. Else. C out one. And essentially, like this would be the solution for this problem. Yeah, like I did a lot of things, and you see, like my in contest summation is slightly more complicated. So like this is the only yes condition, like when n is equal to 2 and difference of those two numbers is greater than equal to 2. Otherwise, you should always print down. So any questions on the first problem before we move on to the next problem? And yes, like I do stream after every contest. And hi Abhinav. Like I won't say like B was easy, like I did found B is slightly hard. Okay, so moving on to the problem B. It says there are 100 rooms arranged in a row and 99 rows between them. The ith door connects rooms I and I plus 1. Each door can either be locked or unlocked. Initially, all doors are unlocked. We say that room X is reachable from room Y if all the rooms between them are unlocked. We know that Alice is in some room from L to R. Bob is in some room from segment L to R. Alice and Bob's are in different rooms. However, you don't know exactly, you don't know the rooms, know the exact room they are in. You don't want Alice and Bob to be able to reach each other, so you have to lock some doors to prevent that. What is the smallest number of doors you have to lock so that Alice and Bob cannot meet regardless of their starting positions in the given segment? So here the problem statement says, we have some rooms from 1 to 100, room number 1 to 100. And there is a path between every two consecutive points. Or probably I think I can draw it slightly better. There is a path from 1 to 2. There is a path from 2 to 3, 4 to 5, 5 to 6, 6 to 7, 7 to 8. And now we have to block some of the roads here. Like for example, we can block this. Now no one can go from 2 to 3. Or we can block 4 to 5. Now no one can go from 4 to 5. Also we can block 6 to 7. Now no one can go from 6 to 7, and so on. And so on, like this story continues here. Now what it says is, like, we have been given a range of position of Alice and Bob. Like for example, let's say Alice is in this range and Bob is in this range. And it asks us to find the minimum number of doors we should block so that Alice and Bob can never meet. It's also given that in starting Alice and Bob's would be in different rooms. So like for example, I can share some samples here. Like let's say 4 and 5, which looks slightly complicated. Bob is either in 4 or 5. And Alice can be from any point from 2 to 4. Now you see, if Bob is here and Alice is here, then they would be able to meet if we do not block this road. So we must block this 4 to 5 road here. Similarly, if Bob is here and Alice is here, then Alice and Bob would be able to meet if we do not block the road between 3 and 4. Similarly, if Bob is here and Alice is here, they will be able to meet if we do not block road 4 and 5. And the answer is, like, these are the only roads we should block. Because if we block 3 to 4, 4 to 5 and 5 to 6, if Alice is in point 2, Bob will be on 4 or 5, but he would never be able to go past 3 here. Similarly, if Alice is between any place 6, 7, 8, 9, and because we have blocked 5 and 6 and Bob is between 4 and 5, he would never be able to meet via this route. And similarly, like 4 and 5 as well, like if Alice is at point 4, then Bob must be at 5 because they cannot be at same position. Or if Alice is at 5, then Bob must be at 5 because they cannot be at same position. And because we have blocked 4 and 5, they will never be able to meet. So here if we block 3 to 4 road, or like let's look at, instead of crossing it out, let's just remove these roads together. Now you see, like, they will never be able to meet each other if we remove these 3 nodes. And essentially, like, this was the idea for this problem. Like first see, like if Alice, let's say if Alice is on range like this, and Bob is on this range, then like you see, like if we block and if we remove any road from this path, then Alice and Bob will never be able to meet. Similarly, this L1 R1 and L2 R2. So if there is no common point where both of them can be at, they will never be able to meet. So like if there are cases like this, then we can directly print one and call it a day. Now Alice and Bob will have some intersection path between them. Now look at the case when Alice and Bob will have some intersection path between them. This would be sum of range where some sets where Alice and Bob would be, and this would be some set where Alice and Bob would be. So for these routes, we will have to block all the roads here. And also notice that if we remove the first road from here, in case Alice is here, he would never be able to go past this road if the very first road here is blocked. Similarly, if the very first road here is also blocked, if Bob is in this area, he will never be able to come this side. And essentially, like, this was the solution. Like, in case Alice and Bob do not have any common point, just block one road which is between like maximum coordinate of one of the point and minimum coordinate of the other point, so that we can directly print one. Otherwise, if both of them have some common places where they both can be at, then in the common area, like, all the roads should be deleted, because anyone can be at any point. And if you have any road which connects them, like for example, like, let's say this is their common area, and for Alice there are some more roads here, for Bob there are some more roads here. And let's say you have removed this road, but you have kept this road from 3 to 4. Now Alice can be here, Bob can be here, and they would be able to meet. And so that's why it's important that all the roads in the common path must be deleted. So now I will jump on to the solution for this. So like, this is one easy way to check over here. Okay, like, probably I can simplify it a bit. So like, generally we check range of it, like maximum of the starting point and minimum of the ending point. This can be the common range if there is any common range. So if minimum endpoint of one of them is less than maximum endpoint of one of them, then this means we are at this case. So we can directly print 1 and call it a day. So we can directly print 1 here. Otherwise, L to R is the common area, and R minus L would be the number of common places there. And if there is some extra place like this over here, then we should delete one road from here. So answer plus plus. Basically, let's say this is Alice places, and this is Bob's place. In this case, we don't have to delete extra road from this side. So only if Alice can stand at a place less than a common area, one of them, then do answer plus plus. Similarly for the right case. Like for example, this is Alice, and this is also the area of block. Then we don't have to remove any extra road from this side, neither any extra road from this side. Because if we remove all the extra roads from this area, we would be good. And like, essentially this is the idea here. So if there is an extra road, like for example, if any of them can be outside the common area we have, so like, this would be the number of roads common at both the places. Okay, wait, like, it should be for both of them. No, both of them can't be more than that. Okay, wait. Like from L to R, number of roads is R minus 7. So essentially this is the solution from problem B. Any questions on this one before we move to problem C? Probably I will move to problem C. Any questions so far? Okay, I will probably move to problem C. It says splitting items. Alice and Bob have n items. They'd like to split between them. So they decided to play a game. All the items have a cost. The ith item cost is AI. Players move in turn starting from Alice. Let's say A is the total cost of items taken by Alice and B is the total cost of items taken by Bob. The resulting score of the game will be equal to A minus B. Alice wants to maximize the score while Bob wants to minimize it. Both Alice and Bob will play optimally. But the game will take place tomorrow. So today Bob can modify the cost a little. He can increase the cost AI of several, possibly none or all items, by an integer value, possibly by same value or by different values of each item. However, the total increase must be less than equal to game. Once Alice may suspect something, note that Bob cannot decrease the cost, only increase it. What is the minimum possible score Bob can help us achieve? So there are few items, like notice that all the items will be taken by someone. Probably let's just play a game here. 10, 15. Like all the items would be taken and S is the sum of all the elements. Then you notice Alice plus Bob score is equal to total sum. Like Alice plus Bob count of both of them. And score of the game is Alice minus Bob. Now you can replace the value of B here. Here the score would be 2A minus S. Or you can also say the score is also equal to S minus 2B. Any of them is fine. Just replace value of B by S minus A, you will get this. Or replace value of A with S minus B, you will get this. And now if you see, Alice's goal should be to get maximum possible score he can get over there. Like maximum possible sum of coins he can get. Because like whatever maximum coins he can get, like Bob will get the remaining one. Similarly, Bob's want to minimize it. So Bob's goal should be to get maximum possible sum of coins he can get, irrespective of what Alice is doing. And once you notice this, like let's say the sorted order of coins is this: A1 greater than equal to A2, greater than equal to A3, greater than equal to A4, and so on. In this case, Alice will always take this, Bob will always take this, Alice will always take this, Bob will always take this, and so on. So like Alice will always pick the maximum coin he can, and similarly Bob will always pick the maximum coin he can. So like this, now like once we know the sorted order, optimal order is always defined. Now let's say this order is 10, 7, 5, 4, and so on. Notice that if Alice changes the 7 to 8, 8 to 9, 9 to 10. In that case also, like Alice will only take this item, and whatever increment Bob has done, Bob will get those extra points. But now in case if Alice changes this 10 to 11, Bob changes this from 10 to 11, then Alice will pick this element and Bob will still get 10 here. So the maximum Bob can increase between these 2 points, this point, so that Alice never picks it up, would be +3 here. Similarly, as if Bob changes this to 4 to 5, Alice will still pick this 5. But Bob changes this 5 to 6, Alice will pick this 5 and Bob will still get 5. And like this is the main idea over here. First we sort all the elements. We know that all the elements at A0, A2, A4 will go to Alice. All the elements A1, A3, etc. will go to Bob. And like number of times Bob can increase A1 would be the difference of A0 minus A1. Similarly, Alice can increase 0.3 would be A2 minus A3 and so on. And like what we can see is like we can see like how many times Bob can increase total score. If that total he can increase without impacting score would is greater than K, then Bob can only increase K times, and this would be the idea over here. So take A as input, sort in the descending order. If it's 0 index, the score goes to Alice, increase plus plus. If it's odd index, the point goes to Bob, decrease it from the total score. And now also maintain the list of when Alice can, how much Bob can increase the point. Which like for all the points which Bob can take, look at the one before it, and the difference of those two elements is how many times AJ can be increased. Now like total extra point Bob can get by increasing something would be minimum of how many times he can increase, and what is the maximum he can increase over here. So basically minimum of these two would be the final answer. It doesn't really matter what points Bob increase, because Bob will always increase something to increase his own count rather than Alice count. And essentially this is the idea for this problem. And probably you can write it in some another way as well. Current operations. C would be like how many operations we can do right now. Then like answer minus equal to C, the Bob count which has Bob increased, and remaining number of operations Bob can do. This can be another way to solve this problem. Okay, odd case is also a bit similar. Like let's say like probably if there is an let's pick some elements 10, 8, 6, 5, 2. In this case Alice will get these elements, Bob will get these elements, and let's say we have 100 operations. So in best case Bob will change this 10 to 9, 9 to 10, and this 5 to 6, and like he would get like 10 minus 10, 6 minus 6 plus 2. So overall score would be 2 here, because whatever Bob increases will end up increasing the score over there. And like this is the idea for this question. Any questions on problem C before we move on to problem D? Yeah, Bob increasing from 10 to 8 won't be good for him. Whatever, like Alice will get this 10, Bob will get this 10, and Alice will get this 8. If you increase this 10 to 11, Alice will take this instead of this. So you will have to increase this as well. You are essentially wasted the operations here. And problem D, colored portals. There are n cities located on a single straight line. The cities are numbered from 1 to n. Portals are used to move between cities. There are 4 colors of portal: blue, green, red, and yellow. Each city has portal of 2 different colors. You can move from city I to city J if they have portals of same color. For example, you can move between blue red city and blue green city. This movement costs 1 I minus J coins. Your task is to answer Q independent queries. Calculate the minimum cost to move from city X to city Y. And like we can probably look at, it can also be possible that it's impossible to move from city I to X to Y. In that case, we should print a -1 here. So few important observations here. Like let me also open it. So let's say this is city X, this is city Y. Here it can have 2 colors. Let's say probably blue, green, and let's say this is red. So like you see, like if we can directly go from here to here, the cost would be Y minus X. And this is the minimum possible cost we can get without doing anything over here. Like we cannot get the answer less than minimum cost we have got over here. And so let's look at the initial color of these X and Y. Let's say this is red blue and this is red green. In that case, it is possible to directly go from X to Y. And we should print Y minus X in this case. Like if these two have any common color, then directly go from this path. Directly we should go on direct path from X to X, Y minus X, and that would be the answer. Or probably in that case, if both of them do not have any color, then you see like this is X, this is Y, this is red blue, this would be yellow green. Like the colors would completely be different from here. So what we should do is like we should find the nearest green we can go, nearest yellow we can go on left side, and similarly on right side we should find nearest yellow, nearest green. Like if we can go to any of these cities, then we would be able to directly go to the Y point there. So that can be one way to go there. Similarly for Y we should look at nearest red, nearest blue on just before it, and nearest red, nearest blue just after it. Like basically these are the different points we should go to, and from one of these points we would be able to directly go to the other point, and like this would be the answer here. Like from X go to some green and then yellow or anything you want over there. That is one way to do it. And what I did for in general was to find out like the nearest for x and y, fix some common color. For that common color, see, go to nearest just before it, go to that common color nearest after it. For y, go to nearest just before it, and for y, go to nearest just after it. These are the 4 possible choices, and among all these possible choices, you find out what would be the minimum pass. So like 4 choices. For a fixed color C, find the nearest color C just before for x, just after for x. For y, just before for y, just after for y. 4 choices here, and 4 different choices we have. Total 16 choices we have over here. And like this was essentially the idea I had. So the problem reduces to, we have color 1, 2, 3 up to n. For fixed color x and color C, find the nearest point of that color we can go. And that is just before it as well. Because if we can find just before it, we can use the same algorithm on reverse to find just after it as well. And the idea I did was to probably use a kind of DP solution. Like we can, if we have x and let's say we want color red, and let's say this is the nearest red color we have. So you notice if we are going in increasing order like this, for this color we would know like how much, what is the nearest blue, green, yellow, red is there. So we can copy the same colors here for blue, green, yellow, and we can keep this red as it is. Similarly, if this point has, let's say, red and green color, we can also look at what the previous green color was, and we can try to copy those values over here as well. And like that was the idea I had for this problem. So first thing I did was to convert blue, green, yellow, red into 4 index, 4 colors, 0, 1, 2, 3, 4. That makes life a bit easy for us. Read answers as input, and x comma y would be the first color, and like basically 2 colors, a vector of pair of integers. Now I have this 4 cross n array, so that I know for each color what is the nearest element just before it. Similar array for each color just after it. So I look at what the color's current element has, and like what was the nearest element with the same color. So the best way to reach that C1x to J would be using the index J only. No, E and F would be the after one. Similarly, like for the second color also, the best way to reach just before it would be J itself. And for all the colors from 1 to n, if we have some nearest element P1, like by default I have set -1, which is outside the range. If we have some element with the same color just before it, then we can use that, like basically P1 and J has one of the common color. So let's say if that common color is green, so you can use this P1, like you can see what is the nearest point with yellow for P1, and that can also be one of the potential nearest point for J as well, because the path would be that nearest point to P1 and P1 to J. So a max over here. And if it turns out that P1 also had the same, we don't really need this check now. And essentially this was the solution I had for this problem. The near array denotes, like, let's ignore all the colors. What is the nearest color with green color, blue color, etc. And previous denotes what is the nearest element we can go from J to the element just before it, which has green color, blue color, yellow color, etc. Similarly, we can go from right to left as well. The same logic holds. Now the idea is, for each query, let's say take x and y. Let's look at the common color. If X and Y has any one common color, then this set size would be less than 4. Directly print those colors. Or we probably don't even need this check as well. Answer is infinity for each color from 0 to 4. Look at the color just before it. From that, go to X. Then, like from X, go to that nearest color. And then go to Y from, or probably I can put it like this. This would be my path. From X, go to the nearest color of color J. From color J, go to the nearest other color of Y we have it. And from that, go to Y. And this was essentially the solution. And if answer is infinity, print -1. Okay, my code editor is Sublime Text. And I will probably move to problem E. Like any questions on this? Can you explain 6 possible? Did not get it. Yeah. So my idea is fix one color C. Then from X and Y, look at what is the nearest color C we can get, which can be just before it or just after it. Similarly for Y, the nearest color C we can go to, just before it, just after it. So 4 possible choices for X and Y, one before it, one after it. And the idea is we go to that color C, and then from color C to C we can directly go here. And like color C can be one of the 4 possible colors: red, blue, yellow, green we have. And like this was the idea I had. Or like I think a lot of simplification is possible for this problem, because if X and Y do not have common color, then color from X would be either, let's say, red, green, then it would be blue, yellow. Like both the, if the 2 color missing here would be the 2 colors here. So we can look at blue, if any blue exists on this side. So we should probably just go to blue, yellow from X. Similarly from white, can we go to some red? Green, like this can be the way. And now like we can probably see an edge would be like this. So basically the idea is just look at, like, for all colors, find for each element what is the nearest element we can go to with that color, and then just try out choices over there. Or like the another way, probably one more simplification over here possible is, let's say this X has color red and green. So there would be some sequence of red, green, and then there would be some blue or yellow color somewhere. And then because Y is blue and yellow, so you can probably go over here, something like that. If there is a common color here, etc. So that can probably be another way. So like I think basically the main idea was there are only 4 colors. If you cannot go directly from X to Y, both X and Y would have opposite set of colors there. So you can try out different possibilities there, and that will give you the idea. Okay, any questions on problem D before I jump on to problem E? Okay, these are not yet active, but I expect them to be. Okay, not a Nim problem. So probably before explaining this problem, what I can do is like I can try to explain like how to brute force on the name theory, number theory problem with some game theory explanation here. Probably I would have like skipped it a bit, but let's probably have some introductory lecture on the game theory. Like I will spend 10-15 minutes explaining that, and then I will jump onto this problem and share how to solve this problem. So I will probably skip proofs here, and I will probably share statements and see like how you can use different ideas there. So like the normal Nim game, we have like generally in the normal Nim game, we have some set of files. Let's say this file has 2, this file has 4 coins, this file has 6 coins. That code would be order n plus q, order n for some brute forcing in starting and then q for answering queries. Like you can answer each query in constant time, but there is also a constant factor to pre-compute ideas there. So let's say we have a Nim game which has 2, 4, 6 coins. In any move, Alice and Bob will play turn by turn. In any move, they can remove any number of coins from any pile. Obviously, you can't have negative coins, but you can pick any pile and remove some coins from there. Let's say Alice starts. And the loser is winner is the one who picks all the last one. Or other way to say is loser is one who cannot pick any coin. So like if you have 2, 4, 6 and 2, 4 and 6 coin, like who do you think would be the winner here? Like because there are no restrictions here, what generally people look at it is like let's look at the XOR of 2, XOR 4, XOR 6. If it is 0, like if XOR of all the piles is 0, then second player wins. Otherwise, first player wins. So like probably Nim game you can probably look out the proof for there, but like I think I can skip the proof here. Like the idea is like whenever like XOR of every element is 0, whoever picks any coin will make it positive, and the second player will have some way to make the XOR again 0. So like basically whenever XOR is non-zero, if there would be one way to remove some coins such that the XOR becomes 0. And if XOR is 0, because you cannot remove 0 coin, you will remove some positive number of coins. So whenever you pick something, your XOR will become again positive. And at last, when you have no piles, your XOR is 0. And like that is the idea. Yeah, like this is the normal Nim so far. Like then like one more variation of Nim is you can pick at max k coins in one go. So far I was giving you unlimited coins, right? Now you can pick at max k coins. Then how do you find who would be the winner here? So what generally people do over here is we create a new array bi equal to ai mod k plus 1 and then look at XOR of all these bi. If this is 0, Bob wins, the second player wins. If this is non-zero, the first player wins. And the idea over here is like at last everything is 0. So whoever loses, whoever is going to play there will definitely lose. And the idea here is you can always keep all numbers roughly some multiple of k plus 1. essentially like if you look at the visualize over there, like the if this is of pile of length k plus 1, like let's say k is 5 here, k is 4 here, then let's group piles like this: 4, 3, 5, 5, 2, 5, 1. Yeah, like where is Zor coming from? Like probably that's a bit identity there, and probably like I can say some blogs on how to read game theory there. Like not a complete introduction, just that I'm trying to play out with different formulas there. Yeah, like Zor and Max will also come in some time. Right now, like I am mostly. The idea over here is just look these bits in isolation. In any game, let's say like Alice removes 4 bits from here, 4 coins. Like right now, what I am saying is k is 4. So like I look at k mod 0, 3, 2, 1 would again be 0. So my claim right now is in this game also the second player wins. How second player can win? I can give you some examples. Like the idea is like we have to remove all the bits again, right? So let's say Alice removes 2 bits from here. Like the idea is to look at this as an isolated game. Let's say from here Bob removes 4 piles. Total 8 piles were there, and now we have remaining 4 here. So what the second player can do is remove 1 pile from here. So that total 5 piles are removed, and we are left with again 3 piles here. Or let's say Bob removes 3 piles from here. What we can do is like we can again remove 2 piles from here. So we would be left with like 1 is gone here, 1 is gone here. We would be again left with 2 piles here. And like this is idea, like the main idea is for each pile we give them some number, and at last we say like if we replace all the piles with these numbers, then now the game has reduced to normal Nim game over here. The way to say here is like 8, 12 and 6, when we can remove at max 4, is equivalent to normal game, where 8 is replaced with 3, 12 is replaced with 2, and 6 is replaced with 1. And the idea is like whenever you remove, like if you make these numbers as 0, like you would have some multiple of 3. Or whenever, like let's say if from this 8 you remove 4 piles and made it 4, so this value becomes 4. Then the other player will have some other choice to bring it back 3 here by removing 1 more pile from here. Or from 12, let's say someone has removed 3 piles. So 9 mod 5 would be 4. So this 2 changes to 4. But again someone can remove 2 piles from here to make it again 2. 7 mod 5 would also be 2, and so on. So generally, like in Nim game, what happens is you have some independent piles. You can do anything from each pile independently. And we try to find out if we convert this game to a standard normal game in the Nim we have, what should be the number of coins on that game. Based on how many coins or what rules we remove some coins, the normal rule can have some different coins there. But that is the first thing we try to do in the Nim game. Why something, probably I will skip, like there are some good books on this one, by the way. Like I don't have a book handy, but I can probably put some book like you can read 1 or 2 chapter there and you would see a lot of many different games. But like this is what we try to do. The first thing we try to do. Now the question is like how do we find like for all the different conditions we have, like what should be the equivalent normal nim game pile we have? That would be the second step I would be doing. But any questions so far? And generally this is what is known as Grundy numbers here. Like in a game which played like this but have different rules, what would be the equivalent normal nim game number of coins is what people call it Grundy numbers there. So like there are some good blocks there. So the next thing is like how do we find the equivalent nim piles there? Let's say we assume a game where we always remove some coins, we never add some coins there. The idea is like we try to compute the equivalent pile from like we run a for loop like this for r equal to 0 to some max whatever we want. And let's say we have 15 piles. We try to see what all other states we can reach there. So if we can remove only 4 piles, the number of remaining piles can be 14, 13, 12 and 11 if we are removing 4 piles. So like these, if we start from 15 and if we can take some number of coins, what are the next other states we can reach here? In this case, it is 14, 13, 12 and 1. So we look at like what is the equivalent pile game for this. For example, for 14, like I know like it would turn out to be 4. 13, it would turn out to be 3. 12, it would turn out to be 2. 11, it would turn out to be 2. Like for now, let's say like these are the value or we can take something else. Let's say based on some different rule, for 14, the number of equal piles in a normal nim game is 6. For 13, it's 1. For 12, it's 0. And for 11, it's let's say 4. So the way to find the equivalent pile for 15 would be to find max of 0, 4, 1 and 6. Basically all the next state. Max of equivalent piles of all next states we can reach. So like this is the idea, second idea we have. Like for all the piles from 15, like we can probably reach 3, 2, or another way to see is like let's say we have a general graph where we have some DAG there. So for example, from 1 you can reach 2. Like you don't have any general rule. From 1 you can reach 2. For 2 you can only reach 0. For 3 you can probably reach 3 and 0. For 4 you can probably reach 2, 1. For 5, let's say you can probably reach 3 and 5. Let's say this is a graph. Like you see, like all the next move can be formed as a directed graph. So like one way you can do is you can start in the topological order, like basically look at 0, you cannot reach anywhere. So this is a losing state. So like because empty set, max of empty set is 0, this has Grundy value 0. For 1, the only next state we can reach is 0, and for the 0, the next state pile would be 0. So max of set which only has 0 is 1. From 2 also the next state we can reach is only 0, and max of 0 would be 1. So this is how I am filling values here. For 3 I can go to 1, I can also go to 0. So max of 0, 1 would be 2. So for 3 the equivalent nim piles here are 2. For 4 I can probably go from 2 or 1. And max of 1, 1 is 0. So 4 is a losing state. For 5, next state I can go is 2 and 0. And max of 0 comma 2 is 1. So like these are the equivalent piles over here. It's not necessarily increasing. Like this is a very general graph which I have drawn. And here is how I am trying to find values here. So the idea in this problem would be same. Like now I will read the problem statement. Two players, Alice and Bob, are playing a game. They have n piles of stone. The ith pile initially contains ai stone. On their turn, a player can choose any pile of stones and take a positive number of stones from it with one condition. Let the current number of stones in the pile be x. It is not allowed to take from pile a number of stones y such that greater common divisor of x and y is not equal to 1. So slightly complicated way to say, but it says like if you have x and if you remove y stones from it, then GCD of x comma y should be 1. That was also said as it is not allowed to take from pile a number of stones y such that greatest common divisor of x and y is not equal to 1. So GCD should always be 1. The player who cannot make a move loses. Both the players play optimal. That is, if a player has strategy that allows them to win, no matter how opponent responds, they will win. Alice goes first, who will win? The same pile. So the problem would be same. For each stone from A1 to AN, I will try to find what is the equivalent number of coins in the normal Nim game if I convert this game to the Nim. You see, like we have a kind of a graph over here. So for example, from 6, you cannot go to 3, or you cannot go to 2. You cannot also go to 3, but you can go to 1. Or from 1, you can go to 0 directly. Or for example, from 7, you can go to any number less than it. Apart from 7, to direct 0 is not allowed. Because in that case, you are removing 7 coins and your GCD would be 7. So like a brute force now I would be doing is, the first thing I did was like I can probably try to formally prove, but I think coding here was a bit quick one. So like what I did was, let's try to find a graph for first 100 vertices, and you see like for first 100 you can draw an order n square graph from all the next edges you can go. So I have this function max which takes a vector b and try to gives me the smallest integer not present there, or I can probably call it a set as well. B dot count, as long as j is present, do j plus plus and return j. Like basically it takes a set, gives me the max of it. Now this g is like equivalent coins. For 0, the equivalent coin is 0. And let's say we'll start from x1 to 100. Let's say y is the number of coins we remove. If GCD of x comma y is, means we can do it. So now I look at what is the equivalent coins of x minus 1. And the equivalent coins for x would be the max of all the coins I could get over here. Like this is brute force way to find all the Grundy values I have. Next thing I did was to print these values. And yeah, like this is the brute force way to generate numbers up to 100. And I noticed some patterns over here. First of all, for even numbers, the value is 0. So if for even numbers, it's a losing state. So let's remove the even numbers here with some assert, and yeah. And next thing I observed here was for 0, for 2 it was 0, for 1 it's 1, and for all the prime numbers the value increases. Like for example, for value 3 value is 2, for 5 value becomes 3, for 7 value becomes 4, 9 is not a prime. For 2 minutes let's ignore it. For 11 the value 5 comes in, for 13 the value 6 comes in, for 17 the value 7 comes in. The crucial idea being, like, whenever you have a prime number, you can remove any number of coins there apart from removing all the coins there. So all the equivalent nim values you have seen previously, you would be able to get them. So the max should increase by 1. For 21 also, like, for 23 also, like, the 23 in with coincidence you can see is the 9th prime number, or for 31 is the 11th prime number. You can notice a pattern here. 47 is the 15th prime number, and like, for prime numbers this is how we are getting the values. And for any other number you can see, like, you can look at the smallest prime factor and that is what the value is. For example, for 3 the smallest prime factor is 3 and the value for 3 is 2, so 27 is also 3. I directly noticed a pattern. There should be a way to prove it, but I just went ahead with it. Or for example, 65, the smallest prime factor is 5 and equivalent number of coins is 3, and you can see for 5 also equivalent number of coins is 3. Or for example, for 77 the smallest prime factor is 7 and for 7 the value was 4. So this gave me the solution. Like, I don't really need this order n square graph. What I can see is, like, for each prime, for 1 the value is 1, for 2 the value is 0. Apart from these two numbers, for all the numbers, find the smallest prime factor and see what count of prime factor it is. Like for example, if you ask me 1001, which is equal to 7 into 11 into 3. So the smallest prime factor is 7 there. So I look at what is the value for 7, and that would be the value for 1001 as well. And that was essentially the count which prime number it is. 7th is the fourth smallest prime number, something like that. So like, this was the brute force. Now I am pre-calculating all the values up to 1e7. For 1 the value is 1. For all the even numbers value is 0. So let's start from 3 and let's also keep the count of how many prime what is the next prime number we have. So if current number is not prime, I am continuing it with the C over here. Then you assign current value to it, like that is the current count. Like 3 would be the second prime number, 5 would be the third prime number, 7 would be the fourth prime number, and so on. And for all the values which have smallest prime factor as j, like the current PVF, like if I ignore all the even numbers, then if they have a prime number, they are not prime, then they would have some smallest prime factor. So this value would already be populated here. So I ignore it. Otherwise, I just copy the value of p is the smallest prime factor I know of. Just copy the value. So this way I pre-calculated values for all the numbers from 1e9. And now whenever I am taking numbers as input, I read as values as input. G2x would be the equivalent number of coins if we have a like the Nim game where we can take unlimited number of coins. So take XOR with this. And if current XOR is positive, print Alice, otherwise print Bob. Like Alice is the first player, Bob is the second player. And this was the solution I had. One second, looks like I'm messing up something. Mhm. Okay, I just see like one thing should be like this should be 1 in 9 plus 1. So like this code, my code can in fact get a TLA, but okay. Because I'm GTX. Okay, I think I'm calculating it fine, but not really sure why. Okay, if this is 0, then only populate it. By the way, I see a bug in my code, but okay, this is less than equal to 1 is 7, right? Okay, and like my for loop was up to 1 is 7 only. Mhm. Not really sure why it is working, but I think one test case with number 1 to up to 1 in 9 should fail you. This should get a runtime error. Looks like there is no test case with 1 in. Not sure why it passed, but okay. Looks like undefined behavior has saved us here. So like code definitely has a bug, but looks like it passes on Codeforces for the undefined behavior. So yeah, where here we are. Any questions on this problem before I move on to F? Like on F, what I did was like these solutions will definitely be hacked today. Like they all are order n cube solutions, but this is order n square log n, and this should pass over there. Done. So I hope at least there are some test cases with 1 in 9 over there. Okay, there are some tests and it looks like my code is passing on the undefined variable. So I think we are good, but yeah, code definitely. Code definitely has a bug, just that undefined behavior can do anything, and in this case, it has decided that in a vector of size 1e9, if you try to look at from 1e7 plus 1 next element, it takes the value 0. I'm not sure why, but it's definitely taking it. And because the trendy for that value is 0, looks like the solution is not hackable, but I won't be surprised if it gets it. So let's jump onto this solution. Let the function f of b return the minimum number of operations needed to make an array be a palindrome. The operation you can make are choose two adjacent elements bi and bi plus 1, remove them and replace them with a single element which is their sum. Or choose an element bi greater than 1, remove it and replace it with two positive integers x and y such that both of them are 0 and their sum is equal to bi. So like we have been given an array. It says at any point we can choose one index, split it into two numbers such that sum remains same, or you can take two nearby element and merge them. And your goal is to make the array palindrome after you are done with some number of operations there. For example, if you have 2, 1, 3, you can split 2 into 1 and 1. This would be the array you would get. You cannot split anything into 2, but you can definitely merge 2 and 1. So in that case, you would get 3 and 1. In 3, you can split it as 1 or 2 or 2 or 1. If you split it as 1 and 2, this is the next element you would get. Or if you split it as 2 and 1, this is the next element we would get. So these are the 4 arrays we can get after doing one operation there. That is the first statement. And then it says like for all the sub arrays, find the minimum number of operations required to make it a palindrome. So let's first forget this value and see like how do we calculate. You have been given an array. How will you find the minimum number of operations there? So any ideas on that? So like I mostly tried to do it proof by AC. That's why like with every optimization I was trying to submit it. So let's first solve it for the full array and try to see how many operations the full array needs. Then we will try to solve it for the sub array. Like sub array will need few additional operations. What I did was like I always use this type of array there, operation there. You can probably use this as well. Okay, question again, please. Sure. It says we have been given an array. We want to make this array a palindromic array. Because it can happen that the initial array is not a palindrome, right? So the idea here is you can do two types of operations. You can choose two nearby elements, remove them and replace it with their sum. Or other than way around, what you can do is you can choose one element and split it into two different elements such that the sum still remains the same. So for example, if you have 2, 1, 3, you can split 2 into 1 and 1. This would be the next array you can get. Or you can merge 2 and 1. In that case, this would be the next array you can get. Or you can split 3 into 1, 2. In this case, this would be the next array you would get. If you split it as 2 and 1, this would be the next array you can get. Or if you merge 3 and 4, this would be the next array you would get. Like the minimum answer, like it can possible that we don't have to split it into single element. So for this example, like you can see like if you split 2 and 1, you got 3 and 3. This is a palindrome. And one more thing was like all the numbers are positive here by the way. So the first idea here was like 2121 is not a palindrome. But here you can change it to 3, 3 and get a palindrome there. Can you give me an array of length 6 and 7? people in the chat, like I will try to show some operations there and try to find minimum for that array. Like samples are not really good here, by the way. No, wait, samples are good. Like, can you just give me an array of 5, 6 length? Okay. 5, 3, 1, 2, 3, and 4. So you see, like at any point of time, so there are two things over here. Like if 5, I will probably modify it a bit. So like let's say this is our array. This number and this number are equal. So let's just ignore them and try to find minimum operations on this array. So now we have this 3 and 4. I have two choices. Either it can split it as 1, 3, or I can combine this 3 with the element, some element before it. Let's do some modifications here as well. Let's say this is the array. 5 and 5 are equal. Now I have two choices. Either I can greedily try to start from here and try to make arrays equal. The way would be like I start with one pointer here, one pointer here. I see like current sum is not equal so far. So I merge these two elements and replace it with 3. Now again the elements are not equal. Let's make this element 2 here. I want to show some stuff here. Yeah. So what I can do is I can probably pick this smaller element here. I can again merge these elements to do some operations. I would get 5 now, and here it's 4. Now what I can do is like now I can try to merge some elements over here. 4 and 1 will be merged. I got a 5 here. So now I have fixed the second element. I move my next pointer over here. And this is how I am trying to find the basic bare minimum operations required over here. And in that case, like whatever, now this array is palindroming, and whatever I have done the operation so far, this would be one way I would try to make it minimum, and my claim was this is the minimum you would be able to get it. And now like I will probably create array again. This was our array. Instead of merging this element here, what I can do is like I can split elements here as well. Like for example, I want to mix with this 2 with 2. So I will split this 4 into 2 and 2. Now these elements are equal. I move further. And now like since this is 1, this is 2, I will split this 1 as 2 as 1 comma 1 again. This 2 has mapped over here. The idea was like I can even try to split this element here. So now to match it with this one, I will split this as 1 comma 1. Now these elements are matched. Now here I have this 2. I can split now this 2 as 1 comma 1 again. And then you will probably see like now this will turn out to be palindrome. This element will match with this with this, and so on. And one important observation was either you split all the time or you compress all the time. If you do it like this, the number of operations would turn out to be same, and it would also be the case that this would give us the minimum operations ever. I did not try proving it, rather I just went ahead and brute force it and saw that it passes all the test result. Like for example, like what is my first submission? Yeah, this was my first submission, which got TLE on test 9. It literally runs 2 for loop, tries to find the answer for L to R. And this one was trying to merge elements here. Like you have one left pointer, right pointer. You look at what is the minimum value of them. Yeah, like split every time or merge every time. So my idea was to split this LE into C comma LE minus C and RE into RE comma C. And one of them would be 0, so we don't really would need a merging here. So if any of them is positive, then we needed a split operation there. So one count plus plus. And if the remaining half of that split was equal to 0, now move one pointer further. So one pointer further and assign LE as LE plus 1, or you can just say LE equal to 0. We don't really need a plus 1. Similarly, on the right side, like if both of the elements are 0, then only LE and RE would be 0. In that case, we have got a merge. We don't need to increase the number of operations. What we have to do is just L plus plus R minus minus. Or if only one of them would definitely be 0 because I am taking minimum of both of them. It would definitely be equal there. So if left side needs a split, like the advanced pointer on left or advanced pointer on right, basically whatever the remaining half match, do L plus plus R minus minus, do it as long as L is less than R. And whatever the number of operations I did, return that and add this for all the answer. This was TLE 9. The next idea was, let's just pre-compute answer for all L to R. And let's do it in increasing order, so that whenever we know L to R, we know all the ranges which start and end between that range. So in increasing order of length, try to find the answer for L to R. The idea is still same, do this processing. But as long as when you need both the answers greater than equal to 0, then instead of trying to do it further, I just look at pre-computed answer for the interval which is inside that. So like what I am doing is, I split all the time. So I start from here, like this is my left pointer, this is my right pointer. If both of them are equal, I just advance one. If both of them are not equal, whatever is the greater element, I split it into 2 different elements and move the pointer further. So there would be a case when all the elements I have formed here and all the elements I have formed here were same. And now I have to increment both left and right pointers. So my idea was whatever operations I have done over here, plus directly look at the pre-computed answers here. Because these elements would be equal, it turns out that this sum is also equal. So like this was one small optimization and it ended up passing in 4983 seconds and time limit is 5. This is definitely order n cube solution, because like it can happen that this condition never hits. In that case, you would never be able to get it over there. And I think I would probably be able to construct some test cases for it. But yeah, like this just gave me conviction that I can continue optimizing this part to get all the answers. So any questions on this brute force approach first before we jump on how to find answer for all the sub-arrays? So yeah, like the problems are definitely hard. Like E, it was just an exercise of do you know Grundy numbers or not? And because I knew the formula, I wrote a brute force course. I just observed the pattern and was done with it. And to be frank, like this is not 70 minutes. Like in this solution, I got an AC. This is the AC one, and like all of these would get TLE audit. So in fact, I needed more than 90 minutes for problem F, not 70. This was the first accepted submission, but this is the first correct submission. These are TLE verdicts. So the next idea was this is our index R, this is our index R. And from our previous observation, what we know is like this would be some set of operations. Afterward, there would be a time when both the pointers would move further. If both the pointers are moving further, it means these elements are equal to these elements. And because we are doing all the split operation, if some of these element is S, some of these element would also be S. So new NL, and let's say this is new NR. And what I am doing is like basically for all the operations so far, I am incrementing one element at a time, and NL and NR would be the first time when I would increment both the pointer. So I can probably use the pre-computed value. So if I have a prefix array, you can probably notice that sum of first n elements, NL element would be equal to sum of n plus sum of first n element is equal to S plus sum of first L elements. If this is the time when I am incrementing, or not NL minus 1. You see like this is element up to L minus NL minus 1 only. Because NL would be the first time I am incrementing. So first of NL element minus 1 would be sum of first L minus element plus 1. And similarly first sum of first R element would be sum of the new right pointer would be sum of first R element minus S. Because if I am incrementing both the pointers together, then whatever elements I have processed on left side and whatever I am processed on the right side, that sum should be equal. No, like I am not planning to do G because I don't know how to solve it. And the idea is like, let's add these two equations. This S and S will cancel out. And this gave me the idea like I can probably combine all the, if this is my starting range from L to R, and this is the first time when I am incrementing, then this value would also be equal to this value of this range. So what I am saying is, like let's say I start from L, I go up to R, and like NL is the first time, like when I increment both the elements together, NL is the new element I get, and nr is the new element I get when I'm incrementing both the pointers together. And what we have seen is like we can probably count how many operations with this we did to make these elements equal, plus we can directly use the pre-computed answer for this part. And the idea was if I am incrementing both the pointers together, then this all the elements I have done split operations here, and all the split operations I have done here. Even after them, like if I am getting a palindrome, then sum of these parts must be equal. So like the last index over here would be NL minus 1, because NL is the new index where I would be going, and the element before L is L minus 1. So if the sum of this element is S, then like sum of first L minus 1 element plus S will give me sum of first NL minus 1 element. Similarly, since it is equal, sum of first R element should be equal to sum of first NR element plus S. So like I have wrote these two equations here. Now the next thing I did was just let's add this equation, because S can be anything and it's a variable here. What I got was like for the new range I would be getting is first of sum of first NL elements plus sum of first NR element must be equal to sum of first R elements plus sum of first L minus 1 element. And this gave me the idea like I can group ranges on this value. And like once I knew this, and what I have seen is if I have to count how many elements remain, if I know this value, then I can see, because I am always splitting, or probably if I look at it the other way, if I am always merging, like I am probably switching between splitting and merging, but there is a reason for it. Or the another way to look at it is instead of splitting, merge all of these elements into one and merge all of these elements into one. So like if I start from let's say 9 elements, and if I always merge and I get 3 elements, then what is the number of operations I have done? If I start from 9 elements, I always merge and I have 3 elements left, then you can see like the number of merge operation is I have done is 9 minus 3, which is 6. So what I am trying to do is for L to R, find what is the maximum number of palindrome each subarray I can get. The idea remains same. I start with L to R. I try to make one large chunk of elements here, one large chunk of elements here, and then I see like what is the maximum number of elements I can get in this range. Like basically greedily trying to find what is the first element I can match from both the sides. And then whatever is the maximum number of elements I can have remaining over here, I can do plus 2 to it to get the elements for this range. And like once I had this grouping, what I did was like for all L to R, all the elements I comma j such that prefix sum of is equal to I minus 1 plus prefix sum of R, such that L is less than equal to I is less than equal to J is less than equal to R. For all the index I and J such that this condition holds, find the maximum elements we can remain over there. I comma j and do plus 2 to it. That would be the maximum element which can remain from L to R. Because whenever this condition hold, I can make some prefix from here and some suffix from the ending equal. Like, because this condition essentially means you started from L, you started a pair. This is some element I. Index I is some index J. This is, you created one combined element by merging elements here. You combined all the elements to, or whatever is the sum, to get an element X over here. You match them, and now you are recursively trying to solve the subproblem for here. So for all the starting prefix of, like, I can create, merge some prefix to get a single element, merge some suffix to get a equal element. And once I have created these two elements, whatever parts remains, like what is the maximum number of elements I can get for all I and j over here. Now I don't even need that greedy idea which I have shared with you in starting. So if I can get this for all I and j, then I know like what is would be the maximum element from L to R. And like this was essentially the idea. And to do that, like after grouping, like we have some set of ranges which I can possibly get over here. Like for example, these are the some potential ranges we can get. So the idea was to do sweep line algorithm over here, increasing order of R, of right endpoint, and if right points are equal right endpoint, then decreasing elements of L was the idea. So I will probably jump onto the code for this one. So like the idea was to group all the elements, and like I also took some empty intervals there, like that I got probably by brute forcing here. Like basically empty interval also, and then like on the same groups, look at all the values we have. Now sort it based on the right endpoint, increasing order of right endpoint, and if right endpoint is same, then sort it in decreasing value of P. Now I have used a range max segmentary. If it was an empty interval, like this essentially means I had one element there somewhere, like not really sure, but yeah, like those were, like this means I have got 0 elements here. Like if it's an empty interval where, because right endpoint is just because the left endpoint, there is an empty interval we got. If left and right endpoints are equal, I have got only one element which is equal over there. So like I am doing a segmentary set over here. Like now I try to query on this sense, try to find what all maximum elements I can get. And the answer over here would be if B is the remaining number of elements that remain, then this would be the number of elements there. And then like because I am using one global array of length n, I have to also reset the values here. And essentially this was the idea. Like there can be some off by one elements here. Like there are some probably off by one problems here, but I think so. Like probably a bit buggy. I can probably look at my in context and try to correct it based on the idea I just said. 0 elements here, 1 element is what I can say. Whatever I can save for you. At least the code looks fine to me. Like probably I will try to manipulate it a bit and try to get a working solution. First, I need a range max segment here. Minus infinity is the default value. Mhm. I agree. Like maximum I can get is like I can merge all the elements here, right? I think this should work. Like because in contest, like I was literally trying to optimizing one after the other. Like this will work, but that's not the correct way. Like, I have to remove also off by one value. This works. Let's remove, do a +1 here. This is range 0. This is range 1. This should not work ideally. This definitely works, but and that mostly like those conditions mostly came from my brute force idea here. Like where is this one? I had these conditions like the idea here was like if when I have the middle element, if I have the only one element, then I would increment both the sides from there. So there should be two elements there. Or if I have just crossed the middle element, then only one element remain there. Yeah, it makes sense. Yeah, I think I can show how it's. Mhm. Okay, here the idea was. Okay, I have this L2 R range, right? If from somewhere I am coming here and this range is at least one, then I would have two saved elements, one from this side and one from this side. So whatever elements remain here, plus two would be the remaining count if someone uses this as a subproblem. Or it can happen that this was the boundary and after right one element came here and one element came here. Like basically the elements were split like this. We got an equal sum. Now you jump left here and you right here. In that case, only one element would be 1 second. So one element from here, one element from here, and that would be the only remaining count we have. So or no, wait, this meant like even in that case, like if we are jumping to an empty interval, which just means that this is my final only remaining element. Because like whenever I cross a boundary without making something equal, then there would be only one remaining element. So this condition was like jumping to an empty, like empty, not even empty, an invalid interval just means like we have combined everything into a single element. So this is the middle element. In that case, whatever the remaining sequence will have only one element. So whatever initial length was, you just compress everything into one element. Or if you jump onto one element L equal to R, which meant ki like you have compressed the left part and right part to form two elements there. So like I set this as the next range over there. And here the idea was R minus L plus 1. Like I think still there should be off by 1 here. So like I am pretty much more inclined towards this. In this case, three elements remain. L equal to are the middle one and then two elements from side. We will always have at least one element and like this would be the count of elements I have. Yeah, I think this one is better. This is how it's working. So if we have jump onto invalid interval, it just means like we combined everything there. I think this should be one or two. Like let me just check it out. Like when you are crossing the border, you have two elements here, and if you are jumping onto the same element, then you have zero elements there. So I think this was my stream for DEF. And any questions with respect to this problem or any other problem? Yeah, like definitely it was quite hard, and like my last submission was just in time. And yeah, I expect these solutions to get help. And looks like this submission will survive, although there is some out of bound access on a vector, but looks like this will survive. So I think this is my solution for DEF. Any questions before we call it a day today? And thanks everyone for joining today. I think I will end my stream now. Thanks a lot, everyone.